For today's video we're taking a look at my 1949 Peta A1 stationary engine, along with the Bitsa generator I built to power with it. Stationary engines were widely used to power all sorts of equipment such as water pumps, compressors, generators, circular saws and various bits of farm machinery. My particular Peta was supplied to Frederick Parker Limited in 1949 and was fitted to one of their concrete mixers. We'll talk a bit more about the engine later in the video and also run through the starting procedure for one of these engines, but first we'll take a look at the Bitsa generator itself. I'd always liked the original Peta lighting sets, but they're quite big and heavy and not entirely cheap to buy, so I decided to make my own generator, using as many parts that I had in stock as possible. It had to be small enough to fit in the back of my van along with the engine so I could take it to shows and rallies. I wanted it to appear oldish and to look fairly convincing from a distance when on display. I'd got an old Lucas C40 dynamo from a Triumph Herald kicking around in the back of the garage. These aren't particularly powerful, with a maximum output of around 22 amps, and more realistically they can run at about 17 or 18 amps continuous. This equates to just over 200 watts of power, not loads, but enough for demonstration purposes or for a low power emergency backup generator. The output from the dynamo is controlled by a Lucas vibrating points voltage regulator that you can see here, housed inside the cabinet. I got hold of a nice 1944 moving coil ammeter with a 20 amp range to monitor the load on the dynamo, and a vintage DC voltmeter with a 40 volt range to keep an eye on the voltage. Ideally this should stay at around 13 to 13.5 volts in normal operation. Next to the voltmeter are two warning lights. I think these came out of a Morris Minor if I remember correctly. I originally planned to have the generator just providing 12 volts, but realistically it was going to be more useful if it could supply 240 volts, so I added a section at the bottom and installed an inverter. After that I added a 1965 voltmeter with a 300 volt range to display the 240 volts. Technically this meter is intended for a 400 Hz system, but it reads correctly so it'll do for now. Next to the 300 volt meter is the on-off switch for the charging circuit. And beside that is the switch for the panel lights. I'd got a collection of old Bakelite switches sitting in a box, so I used some of these on the project to keep the vintage look. Beneath this are the power output sockets. On the left is the 240 volt socket for the old round pin style plugs. On the right is a 12 volt output using the smaller size of round pin plug. And finally in the middle is a 5 volt USB socket, so I can charge my phone while I'm at a rally. For the panel lights I use plumbing fittings. You've got a straight compression joint at the back with a piece of copper pipe inserted, and then a stop end at the front with a section ground out for the light to shine through. There's a standard LED G4 lamp stuffed inside the pipe to supply the light. Inside the main cabinet there is a car battery. This acts as a storage reservoir so you can draw far more than the dynamo's 200 watt output for a short period of time, and then the system can recharge the battery. The upper panel is removable for maintenance and reveals a bit of a rat's nest of wires on the inside. The roof is made of thin sheets of aluminium laminated together to form the shape, with the edges peened over. That more or less covers the generator, so now we can take a look at the engine itself. I bought this engine for spare parts, but when I got it home it seemed a shame not to try to get it running. It had been fitted with a crude gas conversion. The bottom of the carburettor had been removed and this plate fitted in its place, with a pipe for the gas feed and a hole for the air to enter. I presume the mixture was controlled purely by how much you turned the knob on the gas bottle. Obviously I had to get a replacement Zenith 24T2 carburettor. I cleaned up the magneto and the points, rigged up a plastic bottle as a fuel tank and gave it a go. It started, in a cloud of cement dust that was sitting in the cooling fins on the flywheel. So I bought myself a petrol tank. This one is off an earlier Petter, being the rolled and welded type rather than the later pressed type. Once the engine was all together, I decided I wanted to strip it down and paint the tin work. This involved getting the flywheel off. I could do a separate video just about that, but eventually it came off after I'd made 4 different pullers to get the gib key out. At the same time I replaced the big end bearings, refitted the oil splasher or pickup pipe the correct way round, cleaned up as far as I could the slightly melted skirt on the piston, and honed out the worst of the scoring on the bores. I suspect the engine had been run lean and hot due to the gas conversion causing the piston to partially melt. So now I think we can have a look round the engine and see how to get it running. I'll start off by putting a bit of fuel in the tank. This engine runs on standard petrol, but there was a version with a different manifold that ran on vaporising oil. Next, turn on the fuel tap at the fuel bowl. Any sediment in the fuel will fall to the bottom of the bowl, and you can remove it for cleaning by undoing the screw on the bottom. Check the oil level with the dipstick. The level should be between the 2 marks. The oil in this engine is pretty clean, so it's a bit difficult to see, but it's about halfway between the marks, so that's okay. If you need to top up the oil, the filler cap is next to the dipstick. On the other side of the engine is the magneto. This engine uses a standard Wyco Series A magneto. Approximately every 200 hours of use, you should top up the oil by pulling back the brass cover to access the oil hole. The oil soaks into a fibre material that distributes it onto the magneto driveshaft. I might do a future video showing a magneto strip down at some point in time. The carburettor on this Petter is a Zenith 24T2. The main jet mixture adjustment screw is at the bottom, with the drain tap for the float chamber next to it. There is an air bleed screw at the top to adjust the idle mixture. Screwing it in richens the idle mixture and out weakens the mixture. The spring-loaded choke lever is near the air inlet and the throttle linkage is round the back. I've got a modern pit bike air filter on my engine, carefully disguised with paint and a rusty old Jubilee clip. There was just a pipe without a silencer when I got the engine. I have a feeling that's how they fitted them on the concrete mixers. Anyway, I like the vertical exhausts on some of the old Petters, so I took an empty MIG gas bottle, cut it open, made some baffles following the design of the pepper pot exhausts, and then welded the whole lot back together to make my own silencer. And it works a treat. To start the engine, wind the flywheel backwards until it's against the compression. Then attach the crank handle. There are 2 schools of thought about the position of the crank handle. With the handle at the 10 o'clock position, you will be pulling the handle upwards when you reach compression. If the engine kicks back, the handle should just pull out of your hands. Personally, I prefer the 4 o'clock position, so I'm pushing downwards when I reach compression. If the engine's cold, you'll want to hold the choke closed as you start the engine, then gradually release it when the engine is running. My engine is already warm, so I shouldn't need to use the choke, but all of my Petter A1s seem to start better with the throttle closed or nearly closed, so that's what I'll do now when I try to start it. You should only crank the handle a single time. If the engine doesn't start, repeat the procedure, turning the flywheel back against compression and then crank the engine again. If you crank the engine continuously, you're pretty likely to get a backfire because there'll be unburnt fuel vapour in the cylinder, and the spark on these engines occurs every revolution, not just on the combustion stroke. And of course it would probably be a good idea to show how to stop the engine. On the magneto there is a stop button. This shorts out the coil so there is no spark and the engine will stop. Like that. Okay, I've now got the engine hooked up to the generator, so I'll start it up again and get generating electricity. And then once it's running, I'll shut up for a bit so you can enjoy the sound of the vintage engine. I think that's about all for this video. If you've enjoyed watching, feel free to like the video and subscribe to the channel. There'll be more vintage stuff coming soon. So thanks for watching, and I'll see you in a future video.